It's Flashcard Fridays at Math Science History. I'm Gabrielle Burchak. If you've been with me this week and last week, you already know that I've been deep in the world of game theory. And here's the cool part. Did you know that you are a game theorist? You've been doing it your whole life. Every negotiation, every shortcut you kept to yourself, and every time you helped someone because they helped you first, that was game theory. So today, I'm going to give you the vocabulary for game theory. But first, a word from my advertisers. Last week on my main episode, I talked about the birth of game theory. John von Neumann and his minimax theorem, John Nash and his equilibrium, and all the beautiful, strange mathematics underneath some of the biggest decisions in human history. And then on Monday, I talked about how to take those ideas into the workplace, how to negotiate, collaborate, and compete a little smarter. So today's flashcards is 3 cards, 3 concepts, and for each one, I want you to think about a moment from your week this last week where you were already the mathematician, already the scientist, already the strategist, because you were. You just didn't know it had a name. So let's start with flashcard number 1, dominant strategy. That's the term, dominant strategy. The definition would be something like this. A dominant strategy is a choice that gives you the best possible outcome, regardless of what anyone else does. It doesn't matter what the other player decides. Your move is your move, and it's always the right one. Now, here's where you already lived this. Think about the last time you sent a follow-up email after a meeting, even when you weren't sure it was necessary. Maybe the conversation had gone well. Maybe nothing was left unresolved. But you sent the recap anyway, outlined the next steps, and put your name on the action items. Why? Because whether the meeting had gone well or badly, following up made you look organized, accountable, and on top of things. It was the right move no matter what. That is a dominant strategy. Or think about something a little simpler. You're at a restaurant with a group, and you always order the thing you know you love. Not the adventurous special, not whatever everybody else is getting, because no matter how the night goes, you're going to enjoy your meal. That's a dominant strategy. The mathematicians formalized it. They built matrices around it and proved when it exists and when it doesn't. But the instinct, that was already yours. When you find the move that works regardless of the variables around you, you are thinking like a game theorist. Flashcard number 2, the term tit for tat. And this one has a really cool history. In the 1980s, a political scientist named Robert Axelrod ran a famous tournament. He invited game theorists from around the world to submit computer programs that would play the prisoner's dilemma against each other, over and over and over again, hundreds of rounds. The question was, what strategy wins in the long run? Complex strategies, clever strategies, aggressive strategies, they all showed up. And the one that beat almost all of them was the simplest program submitted. It had just 2 rules. Start by cooperating, and then do whatever the other player did on the last round. That's it. Cooperate if they cooperated. Retaliate if they didn't. Forgive immediately if they came back. Tit for tat. Now, here's where you already lived this. Think about a colleague, a neighbor, a friend, someone you've built a quiet, unspoken rhythm with. They covered for you once in a meeting, so the next time they needed backup, you gave it without being asked. They were running late returning your call, so you took a little longer returning theirs. Nobody sat down and negotiated this. Nobody drew a payoff matrix. You just both understood the rules, and you both kept playing by them. That is tit for tat, and it's one of the most studied strategies in all of game theory precisely because it works. It builds cooperation, it punishes defection just enough, and it forgives fast enough that the game can keep going. Axelrod's research showed it outperforms strategies that are sneakier, more aggressive, and more calculating. It's like kindness with a memory, and you've been running that program your whole life. Flashcard number 3, Nash equilibrium. This is the last card, and this is the big one, Nash equilibrium. I talked about this in depth on last week's podcast, but here's a quick version. A Nash equilibrium is the point in a game where nobody can do better by changing their strategy as long as everyone else stays put. It's not necessarily the best outcome for everyone, it's just the stable one. It's the place the game settles when everyone is acting in their own rational self-interest. And here's where you already live this. Think about the time you were in a disagreement with a partner, a coworker, a sibling, and at some point, without anyone officially calling truce, you both just stopped pushing. Not because either of you won, not because the issue was resolved, but because you both quietly calculated that pushing harder wasn't going to get either of you anywhere any better. So you found the place where you could both live with the outcome and just let it be. This is the Nash equilibrium. You reached it intuitively through social instinct and emotional intelligence and probably some exhaustion. But the math describes exactly what you did. You found the stable point and you stayed there. John Nash spent years of his life developing the formal proof for something your nervous system already knew how to do. Congratulations, you're a mathematician. So there are your 3 flashcards for the week. Flashcard 1, dominant strategy, the move that works no matter what. Flashcard number 2, tit for tat, cooperation with a memory. And then flashcard number 3, Nash equilibrium, the place the game settles when everyone stops fighting. You didn't learn these this week. You recognized them, and that is exactly the point of this episode. You are already doing the math. You are already doing the science. You always have been. Pat yourself on the back for that. You are practicing emotional intelligence and mathematics. Innately, you are practicing emotional intelligence and game theory. Innately, that makes you incredibly self-aware and a mathematician. How cool. Thank you so much for listening to Math Science History. And until next time, carpe diem, my friends.